Good afternoon, students. Today in the Unit 11, we are passing to the next topic, that is that superposition principle. When a jerk is given to a stretched string which is tied at one end, so we know that if you are losing that, a wave pulse is produced. That the pulse has to be travels along the string. So if suppose two persons are holding the stretched string on either side means that will also gives a jerk continuously. So what happen means two pulses moves towards each other. So two sides we are having the pulses that will be meeting at some point, right? And move away from each other with their original identity. So that behavior is very different only at the crossing or the meeting points. This behavior depends on whether the two pulses have the same or the different shapes. Like this diagrams has to be given, no? So like this, how the waves has to be formed. See, the first one, the two waves has to be how the two waves, and the second diagram also the waves has to be different shapes, and the next the two waves has to be will be different in the crossing points also. Like that, the superposition of the two waves will have the same or the different shapes. So what they are given means when the pulses have the same shape at the crossing means total displacement will be equal to their sum of the individual displacement. Okay, so how much distance it will be moving from its equilibrium, that will be algebraic sum of their individuals. That means when the amplitude, net amplitude will be higher than the amplitude of an individual pulse. You know what is amplitude? That is the distance moved from its equilibrium. Okay, so that is the distance or the displacement, okay, from the point, that is called as an amplitude. So the amplitude of it is higher than the individual pulses. And when two pulses have the same amplitude means the shapes are 180-degree out of phase at the crossing point. So that means net amplitude will be vanishes at that point. So the pulses will recover their identities after the crossing only. So when we only wave the waves can possess a peculiar property. So this will be happen only for the waves. So such things has to be called as a superposition of the waves. And this means the principle of superposition explains the net behavior of the waves when they overlap. Okay, overlap means you know that what is overlapping. Okay, the waves will be coming one up again one more one, like, okay, so that will be forming one by one, so that is overlapping. So generalizing to any number of waves, that is if two or more waves in the medium wave simultaneously they overlap, their total displacement would be vector sum of the individual displacements. We know that the wave satisfying the wave equation, which is linear second order homogeneously excuse me, partial differential equations in both the space coordinates and the time. So their linear combination, that is often called as a linear superposition of waves, will also satisfy the same differential equation. So to understand mathematically, let us consider two functions which is characterize the displacement of the waves. For example, y1 is equal to a1 sine kx minus omega t and y2 a2 cos kx minus omega t. So both y1 and y2 satisfy the wave equation. Then algebraic sum is nothing but y is equal to y1 plus y2. So this also satisfying the wave equation. This means the displacements are additive. Okay, the displacements are additive. So this will be given here. And if the multiply y1 and y2 means with the sum constants, then their amplitude will be scaled by their constant. That means if c1 and c2 are used to multiply the displacements means y1 and y2, then the net displacement is nothing but y is equal to c1 y1 plus c2 y2. This will be generalized to any number of waves. In case of n such waves is more and then in one dimension, then the displacements has to be written as a vector notation. So the net displacement will be what is given as, if you are having more number of wave means what happen, definitely n number of will be wave has to be there in one dimension. So more displacements you will get, no. So for that we are taking as a summation. If it will be more means, so vector sum. So that's why we are using here the summation. So y vector is equal to summation of y is equal to 1 to n. What is its meaning? So the integers will takes place from 1 to n number of waves. So that will be given as CIYI vector. The principle of superposition can explain the following. That means the space, that is the spatial interference, also known as the interference, or the time, that is temporal interference, also known as a beats. Okay. And the concept of stationary waves. Waves that obey the principle of superposition. The waves that also obeys the principle of superposition, called the linear waves, the amplitude is much smaller than their wavelengths. So if the amplitude of the wave is not small, then they are called non-linear waves. They violate the linear superposition principle. For example, laser. So we will focus our attention only on the linear waves. Okay. Next we pass on to the interference of the waves. What is interference of the waves? That will be paused. So interference, what is the meaning of interference? Means if the phenomena, that is the two waves superimposed to form a resultant wave. So what is the meaning of superimpose? Means one will be overlapping the another wave, that is superimposing that the two waves, that will form a resultant wave of greater or lower or the same amplitude. The amplitude will be more than that or lesser or same. Okay, that is the interference. So consider the two harmonic harmonic waves having the identical frequencies consist constant phase difference, that is phi, and the same waveform will be given, treated as a coherent sources, but having the amplitudes as A1 and A2. So then what is will be the equations? We know that already. Y1 is equal to A1 sine kx minus omega t, y2 is equal to A2 sine kx minus omega t plus phi. So if we moving simultaneously in a particular direction, the interference occurs. That means the overlap of these two waves mathematically will be given as y is equal to y1 plus y2. So substituting the equations in this, that means substituting the values of y1 and y2 in this equation. So what we will get means y is equal to a1 sine kx plus omega t, sorry, minus omega t, plus a2 sine kx minus omega t plus phi. So you know the trigonometric identity of the sine of a plus b, that is alpha plus beta, will be given as sine a sine b sine a cos b, that is sine alpha cos beta plus cos alpha sine beta. So that in that formula, if we are expanding this, means what we will get, y is equal to a sin kx minus omega t plus a2 sin kx minus omega t cos phi plus cos of kx minus omega t sin phi. Okay, so then it will becomes, we are taking the common terms. So what you will get means a1 sin kx minus omega t we are taken as a common. So that will be for the a1 and a2 also. So what it will become means sin of kx minus omega t into a1 plus cos phi is here, right? See the first term, and then the second again we will get that plus a2 of sin phi cos of kx minus omega t. Okay, that means a2 will be common for these two. That's why we are getting again the equation. In this equation, a2 sin phi cos of kx minus omega t. Okay, so a cos theta is equal to what we are getting means a1 plus a2 cos phi. Okay, So the next thing, y is equal to a sin kx minus omega t cos theta plus sin theta cos of kx minus omega t. That will becomes y is equal to a sin kx minus omega t plus theta. So by squaring and adding the equation, we will get that a square is equal to a1 square plus a2 square plus 2a1 a2 cos phi. How you are getting this equation? If you are squaring this equation means it will become, you are getting this value only becomes. Okay, so what is the value means a square is equal to a1 square plus a2 square plus 2a1 a2 cos phi. Okay, so that is the thing we are getting. So what is this formula? A1 square plus a1 plus b a2 a1 plus a2 the whole square formula is this one. So that's we are getting from this adding, we are squaring and adding the two equations, we will get this one only. And what is the next means the intensity in the square of the amplitude, that is intensity is nothing but I is equal to a square, that is we are getting this equation as we are taking a is equal to I, intensity will be equal to the amplitude, so we are replacing that a as a I, so that is I is equal to I1 plus I2 plus 2 root of I1 I2 cos phi. So this will result the resultant intensity at any point depends on the space difference at that point. Okay, so for constructive interference means the crest of one wave overlap with the crest of the another wave, their amplitudes will add up and we get the constructive interference. Okay, the resultant wave have the larger amplitude than the individual wave, that means for individual wave amplitude will be lesser when compared to the resultant wave amplitude. So constructive interference at that point is occurs if there is a maximum intensity at that point, which means cos phi is equal to plus 1, that is phi is equal to 0 comma 2 pi comma 4 pi. Okay, that will be taking up to the 2n pi values, and n is nothing but 1 0 1 2 like that it will be going on. So the phase difference in which the two overlap to give the constructive interference means this will be resultant wave that will be giving the resultant, that is I maximum will be given as root of I1 plus root of I2 whole square, that will be equal to, so the phase difference of two waves overlap means we will get this resultant, that is a1 plus a2 whole square. So what is the resultant amplitude? A is equal to a1 plus a2. Okay, so if you are taking this two root means this will becomes a1 plus a2. So how the waves, see one wave plus adding the another wave means you will get the another wave. If one wave, this is for the constructive interference, and for say the destructive interference you will be getting when overlapping of the two waves will be giving like a straight line. Okay, so what is the next thing? The destructive interference diagram is already given, but what is that explanation means? In the constructive interference we are seeing that the crust has to be overlapping the another crust. Here the destructive interference when the trough of one wave overlap with the crest of the another wave. Okay, you know crest and crest overlapping means that is constructive interference. Trough and crest is overlapping means that is destructive interference. So what happens means amplitude cancel each other, so we get the destructive interference, that means net we don't get a wave formation, just we are getting a straight line. So resultant amplitude will be a 0 1. So destructive interference occurs if there is a minimum intensity at that point. So which means cos phi is equal to minus 1. So phi will takes place of pi 3 pi 5 pi up to 2n minus 1 pi value. So the n will takes the integers as a 0 1 comma 2 comma 3, it will be going on. So this is the phase difference in which the two waves are to be overlapped to give the destructive interference. That means I minimum will be equal to root of I1 minus root of I2 whole square. That will be given as IA1 minus A2 whole square. So what is the resultant amplitude? Means A is equal to A1 minus A2. Let us consider a simple instrument to demonstrate the interference of the sound. So what is that in the simple instrument will be given here means this is the simple instrument. A sound wave from a loudspeaker is sent to a tube P. This looks like a T-shaped junction. So in this case, half of the sound energy is sent in one direction and the remaining will be sent in the opposite direction. See, one will be in the one direction, other will be in the opposite direction. Okay. So the sound waves that reach the receiver or can travel either of the two paths. So distance covered by the sound wave along any path from the speaker to the receiver is called path length. So we notice that the lower path length will be fixed, but the upper path length can be varied by sliding the upper tube is varied. That means the difference in the path length is known as a path difference. So the del R is equal to R2 minus R1. So the path difference is allowed to be either 0 or some integer. So the multiple of the wavelength lambda mathematically given as R del R is equal to n lambda. So you know that lambda is nothing but wavelength and n is an integer that will take from 0 to n values. So two waves are arriving from the paths means R1 and R2 reach the receiver at any instant or in the phase. So that means phase difference will be 0 to 25 values and then the interference constructively given as like this. So here see the two identical waves. Okay. So therefore in this case maximum sound wave intensity is detected by the receiver. So if the path difference is some odd integer, that means some integral multiple of wavelength means mathematically given as del R is equal to n lambda by 2. So two waves are arriving from the path, that means two waves we will receive. If two paths are there, then we will receive the two waves, that is R1 and also R2, both will be reaching the receiver at any instant or out of the phase. So they interfere destructively. So there will be the two waves will be along the path, or it will be receiving the out of phase also. The out of phase means it will be destructive interference. So therefore in this case maximum sound of intensity is detected by the receiver, that is given here. So what happened in constructive interference is also there and the destructive interference also there. So minimum intensity will be the phase difference 180 degree, though they will cancel each other in the destructive interference. Okay, so both the thing will be possible. The amplitude is minimum or zero amplitude, which means no sound. So no sound intensity is detected by the receiver in this case means the relation between the path difference and the phase difference is nothing but 2 pi by lambda. Phase difference is equal to 2 pi by lambda, that is a path difference. That is del of phi is equal to 2 pi by lambda into del R. Otherwise del R is equal to lambda by 2 pi into del phi. This is the difference of between the path difference and the phase difference. Okay, understood what is given here. And next we pass on to the formation of beats. We heard this word beats. Okay, so when two or more waves are superimpose each other with slightly different frequencies, beat. Okay, heart beats. So we know that the beats, what is a beat? That is a two or more will be superimposed to each other. So that will have a different frequencies. Then a sound of periodically varying amplitude at a point is observed. That is known as a beats. So note this, you will get as a 2 mark what is known as beats. So the number of amplitude is known as beats. The number of amplitude maximum per second is known as a beat frequency. So if you have two source there, then their difference in frequency gives the beat frequency. That means number of beats per second, n is equal to modulo of f1 minus f2 per second. That is a formation of beats. Okay, next we pass on to the standing waves. What is meant by standing waves? First, we are going to see the explanation of a stationary waves. When the waves hit the reached boundary and it back to the original medium and can interfere the original waves. So, a pattern is formed which are known as a standing waves or a stationary waves. So, we are considering the two harmonic progressive waves that is formed by the strings that have the same amplitude and same velocity but move in a opposite direction. So the displacement of the first wave is nothing but y1 is equal to a sin kx minus omega t, that is moves towards the right. Now the displacement of the second wave, that is y2 is equal to a sin kx plus omega t, that is moves towards the left. Both will be opposite in directions. Both will be interfere with each other by the principle of superposition. So we know that what is the net displacement, that is y is equal to y1 plus y2. So by substituting all this value in this equation, y is equal to a sin kx minus omega t plus a2 sin kx plus omega t. So we know the trigonometric function, that is y of kx minus t is equal to 2a sin cos of omega t, the sine of kx. Okay. So, we'll getting this equation from the trigonometric form identity. So, we will rewrite this equation that will give the value of this. So, y of x comma t is nothing but 2a cos omega t sine kx. So this represents the stationary or the standing waves, which means that the waves does not move there forward or backward, whereas a progressive or a traveling waves will move forward or backward. So what is the meaning of stationary waves? Means if two waves are there, means the waves does not move forward or backward, but if the progressive wave has to be there, means it will move forward or backward. That means the displacement of the particle in the equation can be written in more compact form. That is that y of x comma t is equal to a dash cos of omega t, that is a dash is equal to 2a sin of kx, that implying that particular element of the string executes a simple harmonic function with the amplitude equals to a dash. So the maximum of this amplitude occurs at the position for which sin of kx is equal to 1. So when the sin of kx is equal to 1, what are the different values of sin will take place of 1. So pi by 2 and then 3 pi by 2 and then 5 pi by 2, like that will be equal to m pi. M is nothing but the half integer or half integral values. The positions of the maximum amplitude is known as antinode, expressing the wave number in terms of the wavelength. So we can express or represent the antinodal positions, that is xm is equal to 2m plus 1 by 2, that is lambda by 2. Okay, so where m is equal to 0, 1, 2, 3 will take. For m is equal to 0 means we have the value of substituting m is equal to 0. So what happened? 2m of 0, that is 0, 1 by 2 means you will get that. What happened? First substituting the value of 0. Anything into 0 is 0, so that is plus 1 by 2, so you will get 1 by 2. 1 by 2 into lambda by 2, that is equal to lambda by 4. So if you are substituting as 1, 3 lambda by 4, and 2 means 5 lambda by 4, that will be going on like that. So distance between two successive antinodes means, so xm minus xm minus of 1. So substituting this values, you will get lambda by 2. Okay, so similarly the minimum of the amplitude a dash also occurs at some points in the space, and these points can be determined by setting that k of x is equal to that is the kx will takes place of the value of 0, pi, 2 pi, okay, like that it will be taking the different values, okay, up to the n pi value it will take. So n can take the integer or the integral value. So elements of these points do not vibrate or do not move. That means the points are called nodes. So before we have said that antinodes, but these elements are nodes. In antinodes it will take the values of pi by 2. In the nodes it will take the values of I. So that does not move actually. So elements that do not move, that is a nodes. So nth nodal position means xn is equal to n lambda by 2. N will take 0, 1, 2, 3 values. Here also we are taking the values of 0, 1, 2, 3. So for different x's we are getting x0 is equal to 0, x1 is equal to lambda by 2, x2 lambda, and so on. So the distance between any two successive nodes can be calculated as xn is minus xn minus 1 is equal to n lambda minus 1 minus of n minus 1 lambda by 2, that we will getting as n lambda by 2. So for both the nodes and the antinodes we are getting the final value as like as a same, that is lambda by 2.